So in the previous class, we have seen the design of top dome and the top ring beam. Barabar? So we will continue today, and we will have the design of now circular ring girder. Okay. So before that, let us try and understand what is this. Okay. So this figure clearly indicates the uh, situation. So you can see there is a column. Okay. So uh, here here we have a column. Okay. So there are six columns like we have designed in the previous class when we have seen the design of circular ring girder or circular ring beam. So this is one column out of those six columns, and from this column there is a corbel which is coming out, which is like this. Okay, it's a triangular portion, and above this there will be a beam. Okay, this beam, I won't call this as beam, we'll call this as girder. Okay, now this is a circular girder, and this circular girder has got a reverse kind of a shape where the depth of the beam is less and the width of the beam is more. Okay, why this is given? Because there is certain purpose that we will see in the next slide. Okay, so above this you can see this is a brick wall. Okay, and here this is also a brick wall. Okay, and you can see over here some tiny portion of the column, it is coming out. Okay, so this is occurs when the depth or the width of the column is more than the width of the brick wall. Okay, so sometimes it is coming out and sometimes it is within the brick wall thickness. I hope this is clear to everybody what is the situation. Now let us move on to the next slide. Now here you see this is the same picture. Here you can see the column is coming out over here, but now there is a green color rail. Okay, can you see this rail over here? This is your rail. Okay, so this is a curved kind of a rail which is installed on this girder. Okay, so this is the basic purpose of the RCC girder, to support the steel rail. Okay, and on this steel rail there will be a steel girder. Okay, जो घूमेगा, right? So the basic purpose of this RCC girder is to support the rail section. Okay, so you can see there are different views. So here you can see this is your back view. Okay, so back view you can see the column is coming out, and here you can see this is the corbel. Okay, so corbel is already highlighted with the green color, you can see. So the basic purpose of the corbel is to support the circular beam or circular girder throughout its width. Okay, because you see, if you don't provide the corbel, what will happen? Only some portion of the circular girder will be supported by the column, rest of the portion will be cantilever portion. So to have the support to the circular girder throughout its width, the corbel is provided. Okay, I hope this is clear to everybody. So if you see the back view over here, and if you see the completed structure which is there on the right hand side, so you can see both are same. So here also you can see some column is coming out and brick wall is there inside. Okay, but in the actual structure you cannot see what is going on, where is your circular girder is not visible in the actual structure. That's why I have drawn this section, so that the situation must be clear to you. Okay, I hope this is clear to everybody. Okay, fine. Now just focus on this. So now if you see this picture, okay, I'm talking about this picture. Okay, so the shaded portion, this is the shaded portion. This shaded portion indicates your circular RCC girder which we have to design. Okay, now you see this RCC girder is supported by 6 number of columns, and it is getting support throughout its width whenever there is a column. Okay, अगर column नहीं होता तो क्या होता? पूरा width में support नहीं मिलता. So now you can see it is just a simple circular girder which is having a 6 support system. right? Now above this circular girder, okay, there is a rail. This is your rail, okay, and on this rail there is a platform kind of a structure, okay. So here this much portion is nothing but your platform, okay. So this platform is a rotating platform. So as you can see in this arrow, okay, this arrow, so it is allowing you to rotate this particular form or this particular platform like this also. It can rotate it in this form, so it is rotating in the circular fashion. At the same time, there is a portion which is shown in this blue color, which can be moved along the length of this girder, okay. This girder in the sense steel girder, okay. So with the help of this mechanism, now you can reach each and every point within this circle, okay. So whenever you want to lift anything with this mechanism, that is the some square platform, it is moving or it is sliding across the length, and the entire platform is rotating, so that way you can reach any point over here. So this is the situation over here, right? Now you see in this particular figure, so I'm talking about this figure now. So in this figure you can see there is a wheel, okay, and the wheel is supported by a rail. So what is happening is this is nothing but your wheel. This is just one wheel, okay. So this wheel will be supporting certain amount of load, okay. So this load we have to calculate first, and once the load is calculated, then it will be transferred to the girder in form of a wheel load, okay. I hope this is clear to everybody, right? Now there are few terms which you need to understand here. If you remember the height of the pump house, we have assumed this as 6 meters, okay. In the problem, if it is given, then it's okay. Otherwise what you can do is you can assume a distance of roughly 1.5 to 2 meters, okay. So this girder is located basically at a distance of 1.5 meters from the top, okay. So all I'm trying to say is above this girder, okay, I'm saying above this girder there is a clear head of 1.5 meter, okay. It is why I'm saying clear head, because the clear head is required for some purpose, maybe maintenance purpose, maybe instrumentation has to be installed over there. So clear head has to be 1.5 meters. That's why the depth of the beam is this distance. I have not calculated from here, okay, no, I have calculated from here, that is from the top, okay. And the rest of the portion is 4.5 meters, okay. Then we have, this is your column, from here to here this is your column, okay. Whereas the shaded portion is nothing but your brick wall, right? So some portion of the column is coming out of the brick wall. And to start with, we have assumed the dimensions of the brick, dimensions of the girder. So the dark black portion, this dark black portion, okay. So this is nothing but our circular girder. So you can see this circular girder is supported from here by column, okay, and from this much portion it is supported by corbel. So throughout widths it is getting support now, right? Now, so what I am assuming that this much portion is nothing but your width of the section, okay. So width of the section I am assuming this as 230 plus 400, that makes 630 millimeters, okay. So this will be the width of the girder, RCC girder rather. And the depth of this RCC girder, I am assuming this as 250 mm. Then this corbel, so corbel will be, ideally it should be like this only from here to here, but it will be also part of your beam. So the total depth of the corbel will be now 450 mm. This is what I am assuming right now. So with these assumptions, now we have to proceed further, right? Now, apart from this, we have a proximity. So here, this proximity will be given to you, or you have to assume this as 1 meter. This proximity means what? Since this is circular in motion, okay, it is moving in the circular direction, and as well as this particular platform is sliding like this, okay. So there is a limitation. you cannot move this particular platform up to certain distance, क्योंकि इसके बाद तुम्हारा section खत्म हो जाएगा. So this CG of this particular platform will come somewhere over here, but it cannot pass this particular range. ठीक है, इससे आगे वो नहीं जा पाएगा. बराबर है. So this distance is nothing but your proximity. So your CG of the platform can reach up to only 1 meter. Okay, उससे पहले नहीं जाएगा. So this is nothing but a proximity. Okay, it totally depends on the instrument size which are installed on the steel girder. Okay, so with this assumption, now we have to proceed further. Okay, so I want all of you to draw this figure very nicely. Okay, just the top one. Okay, and the sketch which is written over here. एक काम कर रहे हैं, मैं इसको वैसे भी ग्रुप में डालने वाला, so we'll be little bit fast. I hope you have understood this. Okay, online students, have you understood this?
Yes, sir.
Yes,
Yes,
sir.
Fine. So we'll continue now. Right. So to start with the design of gantry girder, so this gantry girder is having RCC type of a girder. So the weight which has to be lifted, okay. So sorry, this is a steel girder. I'm sorry. See, I am talking about this girder. Okay, this is your gantry girder. The portion which is over here, this is nothing but your gantry girder. This is a steel girder. Okay. Okay, I'm not. We are not going for steel design, but that some component of the load has to be transferred over there. So for that purpose, for load calculation only, we have to go for the this one. So the steel girder. So this is we are talking about steel girder. Okay, so let me write down over here steel. Okay, so the weight to be lifted. Now this steel girder. Okay, the steel girder, the basic purpose of this steel girder is it should be rotating. Okay, and the purpose is to lift the pump. So whenever there is a pump which is installed on the ground floor, it is subjected to some maintenance and we have to lift that pump for the maintenance purpose. So for this purpose, this particular steel girder is used. Okay, so the weight to be lifted, so totally it consists of weight of the pipe which are already attached with the pump plus weight of the pump plus some of the additional fixtures. Okay, so this will be given, or if it is not given, you have to assume. In actual site, you have to find out all the components and you have to find out its weight. So the weight which has to be lifted is 50 kilonewton, which is given to you. Then the proximity, I have already explained you the proximity. So proximity is 1 meter. Then the weight of the steel girder. Okay, so here steel girder is already designed. This is what we are assuming, and since it is designed, it will be having some sections, and with the help of those sections, now we have to find out what is the total weight of the steel girder. Okay, so in the problem, the steel girder weight is given to you, that is 10 kilonewtons per meter. Now since everything is moving, it will be having certain impact factor, because during the movement some impact will be there and that impact is going to create additional load. So we are assuming the impact factor of 25%. Okay, so if your load is 1 kilonewton, so after impact it will be 1.25 kilonewton. Okay, it's very simple. Then the distance between two wheels. Okay, so here you see, here this is first wheel and this is second wheel. Okay, so this distance is usually it is given. So in the problem it is given as 1.2 meters. If it is not given, then you can assume whatever is the span of the girder, just go for 20% of that. That is 0.2 into span of the girder. Okay, so here the span of the girder is 6 meters, because you see the clear diameter of your pump house is 6 meters. Okay, so along the 6 meter the girder has to move. So 0.2 into 6, that comes out to be 1.2 meters. Okay, so the distance between two wheels has to be taken as 1.2 meters if it is not given, right? So now with this basic information, let us calculate the loads. Okay, I am still on the steel girder. I have not yet moved on the RCC girder. Okay, okay, so this is our steel girder. So if you see the steel girder, it looks like this. Okay, so it's a simple beam. It is simply supported beam. The length of that beam is 6 meters. Why I'm taking 6 meters? Because the clear diameter of the pump house is 6 meters. Okay, and this beam is subjected to a UDL of 10 kilonewtons per meter. Why I have taken 10 kilonewtons per meter? Because it is the self weight of the structure. Okay, this is already given to you. Then the weight which has to be lifted by the steel girder is 50 kilonewton. This is also given to you. So this 50 kilonewton load has to be lifted. It can, that 50 kilonewton load can be acting over here, can be acting over here, can be acting over here. Okay, but the proximity is already given to you. You cannot have a load of 50 kilonewton which is acting over here. Probably this is 0.5 meters. No, you cannot have. Why? It cannot move further 1 meter. So right now we have only two loads. One is a self-weight, which is 10 kilonewtons per meter, and the concentrated load of 50 kilonewton, which can move only up to 1 meter. Okay, 1 meter से ज़्यादा नहीं जाएगा. So can you tell me what will be the RA? Okay, RA, because if you do the simple calculations, RB will be having smaller value and RA will be having larger value definitely. Okay, what will be the RA? बताओ. 71 point. Yes, someone please confirm. 71.66 kilonewton. Okay, तो यहाँ देखो. So if you see the 3D view, I'm talking about this view. Okay, so if you see the 3D view, so on this girder, okay, there will be a UDL. So UDL will be something like this, and this is your 50 kilonewton. So RA, so when I say RA, it's a combination of this wheel load. बराबर है, both. So in this view, although it looks like one arrow, but if you see here, it is two arrow because there are two supports. Okay, so this RA is coming out to be 71.66. So this is 71.66 and impact factor is 25%. So what we have to do is you have to multiply this by 1.25. How much is the impact factor, RA value after the impact factor? That is 71.66 into 1.25. Sorry, कितना है? 89.57. Okay, so this is 89.57. So this is RA, that is reaction at end A. But at end A there are two wheels. Okay, so one wheel load will be 89.57 divided by 2. Correct? So this is wheel load, that is 89.57 divided by 2. How much is this? Sorry? 44.78. Someone please confirm. 44.78 kilonewton. Okay? So this is one wheel load. Okay, and this is the worst condition, because if your concentrated load is acting at the center, in that case your wheel load will be lesser, of course, isn't it? So if it is directly acting at point A, then it will be even higher, but you cannot move up to point A because there is a limitation. Okay, so this is the maximum wheel load which you can get on the RCC girder. Okay, this is nothing but a reactions of steel girder. So we have calculated successfully the wheel load which is acting on the RCC girder, and the wheel load is 44.78. Okay, then the distance between two wheels. So when I say distance between two wheels, I'm talking about this. Okay, so this is 0.2 times the length. So here this length is 6 meters, so multiplied by 0.2, so this comes out to be 1.2 meters. Okay, if it is not given, then only you have to use this. Otherwise you have already designed the steel platform, so you already know what will be the width, so accordingly you have to choose. Okay, so we are going with 1.2 meters, right? Now with this, now we have to design the RCC girder. So now the steel girder we have not designed, but we have just only taken the loads of that. Now let us focus on the RCC girder. So now your RCC girders look like this. It is curved in nature. Okay, and we have to design basically a curved beam with a size which is something like this. The width of this girder is more and the depth of the girder is less. Okay, this is a unusual scenario. Okay, and why it is there? Because we have to keep a rail above this. That's why we are keeping it like this, right? So now if you see the figure which is over here, so you can see the effective radius is 3.115 meters. Okay, why I'm saying 3.115? Because if you see the diameter over here, यहाँ तक जो diameter है आपका ये वाला, this diameter, clear diameter is 6 meters. Okay, and your this is 6.23 meters, this is 230 meters. Okay, यहाँ से लेके यहाँ तक कितना है? 230 meters. So 230 from this side, 230 from that side, that becomes 460. So the diameter which is over here, okay, so diameter which is over here, this is 6.46 meters. Okay, so if you take the average, you will reach at this height, जो center line है. So the center line, this is nothing but 6.23 meter diameter. बराबर है ये? ठीक है? So if you take this diameter as 6.23, so the effective radius is exactly half of that. So the effective radius is coming out to be 3.115, which is exactly the half of 6.23 meters. Okay, so this is the effective radius. So now we have to find out what is the span of your gantry. So the span of the gantry, so your gantry, RCC gantry girder is circular in shape. So what we can do is we can we can find out the perimeter of the circle, okay, and then divide it by number of columns. It's a simple straight away formula. So this is 2 pi r. So this is r value will be 3.115 meters and number of columns will be 6 meters. So not 6 meters, only 6. Okay. So 3.115 into 2 into pi. So this gives you the circumference of the circle divided by 6. How much is this gantry of the length of the gantry girder or the span of the gantry girder? Two point 3.26 meters. Okay, so this distance, okay, this is nothing but 3.26 meter. So this is the curved length of the girder between two supports, that to center to center. Is it okay? Shall I proceed further? Okay?
Yes, sir.
Okay. So now we have a different scenario now. So I'm talking about this RCC gantry girder now. So just now we have seen that the length of this girder is 3.26 meters. Okay. So I'm talking about RCC girder, right? Now this RCC girder will be subjected to two wheels. ठीक है? तो दो wheels जो है, every wheel has got a weight of 44.8 kilonewtons. This we have already calculated over here. ये 44.78 है, तो we can have 44.8 kilonewtons over here. ठीक है? So here 44.8 kilonewtons. Now here you have two situations. Okay, one is when you keep both the wheels exactly at the center, so that you can get maximum bending moment. Okay. Second situation is you can keep both the or you can keep the wheel load just very nearer to the support, so that you can get the maximum shear force. बराबर है? So both the situations has to be handled. So here if you see the figure which is there on the left hand side, so there both the loads or both the wheels, they are kept exactly at the center. So you can see the loads or the wheels, they are separated by a distance of 1.2 meters. So that gives you 1.03 meters on the left hand side and 1.03 meters on the right hand side. And if you calculate the reactions, they are going to be same as your wheel load, because there are two wheels. So there are two reactions exactly center. So it will be remaining same thing. Okay. But if you calculate the maximum bending moment, So maximum bending moment, if you see the BMD of this particular figure, let me draw a BMD for this. Okay, so whenever you have this kind of a structure, you get a BMD which is something like this. Okay, ऐसा कुछ कुछ आएगा ये ठीक से नहीं बना है. Let me draw. It's kind of a trapezium. It is like this. Okay, so the maximum bending moment will come over here at this section. So all we have to do is just multiply this with this distance. Okay, so the bending moment which is just below the wheel, that comes out to be 46.118 kilonewton meter. Is it okay? ठीक है. Now the second scenario is maximum shear force. So the maximum shear force is when you have the wheel which is very near to the support. तो यहाँ पर आपको सबसे ज्यादा shear force मिलेगा. बराबर है. Okay, so for this all we have to do is you just do this, use this equation. Okay, that is 44.8, which is the your wheel load, and then oh sorry, this is not the reaction value, these are not the correct values. You have to calculate the reactions. Okay, and accordingly you can get the shear force value as 44.8 multiplied by 1 plus this is 2.06, which is this distance, divided by the 3.26, which is the maximum span. So the maximum shear force for this situation, it comes out to be 72.7 kilonewtons. Is it okay? ठीक है?
Yes, sir.
Okay. So just note down these values. The maximum bending moment, which is due to the wheels only. Okay, here we are talking about wheels only. Okay, these values will be required for further calculations. So due to wheel, the maximum bending moment is 46.144, and the maximum shear force due to wheel is 72.7 kilonewtons. Okay, so now the external loading is done. Now let us talk about the self weight. Okay, so if you see the self weight, there are different types of load which are coming on the girder. Okay, remember your girder is curved in nature. Okay, above this girder there is a brick wall. Okay, we have already seen in the figure in the previous slides. So we first of all we need to calculate what is the dead weight of the brick wall. So if you remember, while designing the this top ring beam, we have assumed this distance as 0.4 meter, that is the width of that is the depth of the your ring girder. Okay, ring beam, and we have assumed this clear span. Remember, I have used the word clear span of 1.5 meters. Okay, so if you deduct 1.5 or if you deduct 0.4 from 1.5, so you will get a brick wall. So brick wall is having a total height of 1.1 meter. बराबर है? And we have assumed the width of the brick wall as 230 millimeters. Okay, so here you can see this is 230 millimeter, right? So this brick wall will be, so the height will be 1.1 meter, thickness will be 0.23, density of brick wall, let us say 20. Okay, usually we take the brick wall density as 20. How much is the weight of the brick wall? कितना आ रहा है? 5 kilonewton per running meter. बराबर है? Plus we will be needing this self weight of the beam. Okay, so self weight of the beam, if you turn back, we have assumed the width as 630 mm and depth as 250 mm. बराबर है? So 630 by 230, so this is 0.63, depth is 0.25, density is 25. How much is the self weight? कितना आ रहा है? Sorry, 3.93. So this is 3.93. Okay. So if you add these two, how much is the total weight? Something like 8.99. So in place of 8.99, can we go for 9 directly? Okay. So we can have here this has 9 kilonewton per meter. Okay. So basically now we have a curved beam. Okay. It is having a UDL of 9 kilonewtons per meter. Okay. So if you take this value, okay, so right now we are not considering this as a curved beam. Okay, we are considering this as a straight beam. Okay, so if you consider this as a straight beam, now you have a simple straight beam which is having the span of 6.26 meters, which is nothing but curved in nature. So this is the total length of the girder, and it is subjected to UDL of 9 kilonewtons per meter. So in that particular case, you will have the maximum bending moment at the support. बराबर है, because it's a continuous beam. So bending moment will be WL square by 12, and the maximum shear force due to the self weight, it will be WL by 2, where W will be 9 and L will be 3.26. Okay, give me the values of SFD and SF and BM.
7.97
Which one?
BM.
SFD, sorry,
BM.
7 point
97.
and BM 14.67. This is kilonewton and this is kilonewton meter. Okay, so now we have two values of bending moment. One is due to the wheel load and one is due to the self weight. Okay, we have two values of shear force. One is due to the wheel load and one is due to the self weight. Okay, so now we have to combine it for designing purpose. Okay, so let us take the bending moment first. So bending moment, it will be due to the wheel load as well as due to the UDL. So due to the UDL, we have already calculated the bending moment value as 7.97. So let me write down over here. So this is 7.97 and shear force is 14.67. 14.67, and if you see the wheel load, bending moment value is 46.144. So this is 46.144, and the bending moment shear force value is 72.7. Okay, so just please add them and give me the values, please.
54.114. First one.
54.114.
4.
Someone please cross check. Okay, and how about this one? Shear force
87.37.
kilonewton. Okay, so we know now the final values of bending moment and shear force. So all we have to do is just do the simple design. Okay, so here the basic idea is we are not going for the curve design. Okay, so curve design will be more complicated, and we have already overestimated the loads, because you see the bending moment we have calculated. Let us say if you see the bending moment due to wheel load, it is not acting over the support, it is acting just below the load. Okay, the locations are different, right? So if you see the maximum bending moment due to the UDL only, it is there at the support. So effectively, whatever value of bending moment we are getting, 54.114, it is already on the higher side. If you do the exact calculations, it will be even lesser than that. So we can take we can compensate this, and we, in place of going for circular design, we can even go for a simple design also, because your values are on very higher side. So for this much of bending moment, now you can calculate the values of depth which is required. So moment of bending moment is nothing but moment of resistance. So this value is 54.114 into 10 to the power 6 equals to, what will be the value of Q? Sorry, 1.527. Okay, and what will be B over here? 630. Okay, because the width of the beam is 630 mm. Okay, into D square. So how, solve this and give me the value of D. Sorry, ठीक है. And what exactly we have provided? हमने टोटल डी कितना लिया था, एज्यूम कितना किया था? 250. So is it going to work? I don't think, because if you add, so this is the depth is, let us say, 237 plus clear cover plus half of the diameter of the bar. So clear cover, if you take 20 and if you take 10 mm dia bar, so effective cover comes out to be 25. So if you add this over here 25, so definitely how much you are going to get the total depth? So ये आएगा तुम्हारा 262 mm. बराबर है. So this is greater than what we have assumed. Okay, so this is not going to solve my purpose. So what we have to do is we have to redesign this. We have to assume the greater depth and we have to redo the calculations. Okay, so so what we can do is, can we go for 300 mm? I think we can go for 300 mm, because if you go for 300 mm, the self weight is going to get increased and it is also going to increase the bending moment. But definitely, since the depth is more, so it will take care of the value of this one. So what I'll do, I'll slightly go back. Okay, let me go back over here. Now let me use some different color so that you can identify this one. Okay, so in place of this 25, okay, if I go for 0.3, what will be the bending moment value and what will be the shear force value? Please tell me. बताओ, थोड़ा सा ही बढ़ेगा. सेल्फ वेट कितना है? 4.725. अच्छा, ब्रिक वेट तुम्हारा सेम रहेगा, इसमें कोई चेंज नहीं आएगा. ठीक है. सो द टोटल यूडीएल, ये 9 की जगह कितना हो जाएगा अभी? इट विल बी 5.06 plus 4.725. How much is this? Sorry, 9.7885. Okay, so if you use this value, what will be the bending moment and what will be the shear force due to the self weight? कर लेते हैं. बीएम कितना आ रहा है? 8 point, oh sorry, 8.66, and shear force 15.94. Okay, so accordingly the values, if you see, the values are slightly changed. Okay, so in place of 7.94, now you have 8.66. Okay, and here the shear force value is 15.94. ओके, तो ये वैल्यूज तुम्हारी बढ़ जाएगी थोड़ी सी, है ना? हाउ मच विल बी द टोटल बेंडिंग मोमेंट नाउ? 54 की जगह 55 आ जाएगा, 54 पॉइंट। और बेंडिंग मोमेंट, शेयर फोर्स 88 समथिंग, 88.65 kilonewton. This will be kilonewton meter. So now this value will be 54.88. Can someone tell me what will be the value of T? Sorry, 238. कुछ ज़्यादा फर्क नहीं पड़ा. Okay, so I think we can go ahead with 300 now. Okay, so what we can do is finally, okay, so finally we can have this capital D as 300 mm. Okay, and you can take, say, diameter of the bar as 10 mm, clear cover as 25 mm. So the effective will be 300 minus, sorry, clear cover will be 20 minus 20 minus 5, so this comes out to be 275 millimeters. ठीक है, so we can go ahead with this. So your effective depth will be 275 millimeters. Okay, so now with this, now we can calculate the total AST which is required, right? So the bending moment, if you see, so the final bending moment was 54.8 kilonewtons. So this value is 54.8 into 10 to the power 6. Sigma ST is 130. J value कितना है? 0.86. Are you sure? 0.86. Okay, and D value is 375 mm. How much is the AST value, please? क्लास में बाद में बात करता हूँ. Yes, AST please. Sorry, 1307 millimeter square. Okay, and as per IS 456, yes, is there any difference? Sorry, small d is 275. Sorry, my mistake. 275, not 375. Okay, बराबर है ना? 1 millimeter square. Is it okay? Okay, and how about minimum AST? 0.15% of the cross section area. Sorry, yes, Kunal. 283.5. So this is very small value. Okay, so so you require a huge amount of reinforcement, that is 1782 mm square. Okay, so can anybody tell me how many number of bars are required for 10 mm dia bars? Because while calculating the cover, while calculating the effective depth, we have used 10 mm dia bars. 10 के कितने बार लग रहा है 1782 के लिए? 23. So it's very large value. Okay, so we have to increase the diameter of the bar. Okay, if we increase the diameter of the bar, then AST requirement will be slightly changed. Okay, so don't bother about that. So I'm thinking that 10 is not sufficient, so we can go for 12. 12 will also be not sufficient, so let us directly go for 20 mm dia bars. So 20 dia bars, how many number of bars are required? 6 bars are required. Okay. So what we can do is we can provide 6 numbers 20 dia bars. Now this bar we have to provide on both the sides. Okay, when I say both the sides, so I am saying the top side, this is 6 numbers 20 dia, at the bottom also 6 numbers 20 dia. Okay, because you see we have designed this beam as a straight beam. Ideally this is not a straight beam, this is a curved beam. Okay, and there are various types of loading and there is a dynamic loading also. So whatever AST is required, sometimes if you see the bending moment diagram of this one, due to the self weight, so negative bending moment is there at the top, but if you see the wheel load, the bending moment is there at the bottom. ठीक है, दोनों अलग अलग लोकेशन पे. That's why what we are doing is whatever AST is required, okay, that AST has to be provided at the top, at the bottom as well. Okay, this is a very conservative side of design, but since looking at the importance of the structure, so it has to be provided, and it is just one beam, so I think we can manage that. Okay, so 6 numbers 20 dia bars has to be provided at the top as well as at the bottom. Okay, now I hope with this the depth calculation is clear to everybody and AST calculation is clear to everybody. Okay, now let us quickly see the percentage of steel. Okay, that is 100 AST divided by B into D. So here the AST value, okay, so AST value is 6 numbers into pi by 4 into 20 square. Your B value is 630 mm and your D value is 275 mm. Okay, you can even take now 265 because your diameter of the bar is now 20. ठीक है, sorry, 9, because shear has to be calculated at the top or at the bottom. वो अगर तुम 12 करोगे ना तो बहुत ज़्यादा AST आ जाएगा उसमें. कितना आ रहा है AST? Sorry, AST नहीं, PT, percentage of steel. 1 point, it's a large value, isn't it? So 1.08 percentage. Okay, so now let me just quickly go through this from the table which is given in IS 3370 part 2. Probably it is table number 2, which is having the tau c values with percentage of steel. So you have to refer that table, you have to find out tau c, and accordingly you have to just simply do the design. Okay, so do you have this IS code? Anybody? tau c कितना आ रहा है? IS 3370 part 2, table number 2, I suppose. Volume. So I think IS 3370 part 2. Yes, it is in table number 2. No, sorry, not it is table number 3. Okay, our AST is coming out to be how much? 1.08. So if you refer this table, so let us keep 1.08 की जगह पे हम लोग 1 लेते हैं. ठीक है, so if you see the value of 1% of steel, the tau c value is 0.4 newtons per mm square. Okay, so we can just roughly say it is 0.4 newton per mm square. Okay, so this is 0.4 newton per mm square. This is the permissible stress in concrete for shear with the given percentage of steel, 0.4. Okay, otherwise you can directly interpolate and all, hardly it will come 0.41. ठीक है, so for the time being we'll keep this, And if you calculate the shear stress, so shear stress will be the total shear force divided by the cross section area. So the shear force is 88.65. Okay, so this is 88.65. Your width is 630 and depth this is 275. Okay, how much is the shear stress now? कितना आ रहा है? Sorry? Yes, this is 0.51 newtons per millimeter square. ठीक है, so you have a larger stress to deal with and the permissible stress is less. So in that case, now we have to go for the shear design, and for that we have to calculate the design shear force. So design shear force is basically the actual shear force minus the shear force which can be resisted by the concrete with the contribution of the given steel. Okay, so how much is that value? Someone please calculate. I hope you know this. आता है ये सबको? Okay, so basic thing. So the total shear force is I think 88 points. This is something like 88.65. This is in kilonewtons, right? So I'll just keep it 10 to the power 3. Your VC, okay? So VC is 0.4. Okay, so this is 0.4. This is the permissible stress into area is 630 multiplied by you have 275. Okay, I should have written over here, but anyway, how much is this? This will be in newtons now. Okay, because everything I have given in newtons and mm. ये मालूम है ना सबको? Come on, quickly tell me कितना आ रहा है डिजाइन शेयर फोर्स? अरे बताओ भाई. Sorry, kilonewton, 19.35 kilonewton, right? So this is 19.35. This is in kilonewtons, right? So accordingly, now we have to calculate the spacings. Okay, so before calculating spacing, we are assuming that we are providing two leg 10 mm diameter bars as a shear reinforcement. Okay, so for this purpose you have two equations, sigma st asv into d divided by vs plus this. ठीक है, इसमें से जो मिनिमम है वो आपको प्रोवाइड करना है एज अ स्पेसिंग फॉर द गिवन shear reinforcement. How much fy you will be taking? 415. And sigma st how much you will be taking? 130. Do it. So this is 130 and this is 415. बाकी तो तुम लोगों को पता ही है. पहला स्पेसिंग कितना आ रहा है? अरे बताओ भाई. How much ASP you are taking? 2 into pi by 4 into 10 square, right? VS you have already calculated 19.35. अरे पहला तो स्पेसिंग बताओ यार. 290. Okay, so this is coming out to be 290. And how about second one? Sorry, 5515. Is it okay? Someone please cross check. So how much you will be providing then? In place of 290, you will go for 275. बराबर है? So this distance. So this distance will be now 275 center to center. अरे क्या हो गया? 225 आ रहा है. ओके, कोई बात नहीं. अच्छा, ये वाला करेक्ट है, तो ठीक है ना, हम लोग 225 पे दे देंगे. ठीक है, तो जो ये तो बेसिक चीज़ है, ये क्या पढ़ाना अभी तुम लोगों को. ठीक है, शैल वी मूव अहेड. ड्राइंग अच्छे से देख लो, बिकॉज दिस इज अ lateral व्यू in which you can see the shear reinforcement, and this is the sectional view. So here you can see the main reinforcement. Okay, I think I have drawn 7 bars. Okay, but you have only 6 bars at the top and 6 bars at the bottom. Okay, anyway, so let us quickly come to the next topic. This is the design of corbel. Okay, so now like I said earlier, the basic purpose of the corbel is to give the support to the curved gantry girder. Okay, so that the gantry girder can have the support throughout its width. Okay, so for this purpose we have assumed some of the dimensions. So here you can see in this particular figure. So this is a kind of a trapezoidal kind of a shape, and this is nothing but your beam. So the corbel, some of the portion is getting contributed by the beam. Okay, और नीचे वाला जो portion है वो आपका corbel वाला है. So here what I am assuming this is, you have the this depth. तो ये आपका depth क्या हो जाएगा अभी? 300. हमने 300 करके किया हुआ है, तो this is not correct. बराबर है, we have assumed this as 300. So this will be my 300, and here this much depth will be my 450. This I have assumed. And the width, ये आपका width है. So this width I am assuming this as 230 mm. Okay, this is the width of the corbel. So based on this, so let me make some corrections over here. So this will be 300, this will be also 300, right? So now while designing this, what we have to do is we have to consider the value of bending moment and shear force due to the wheel loads only. The same value has to be applied over here. As such, there won't be directly bending moment because it is directly attached with the your girder. Okay, so it is a part and parcel of your girder. So for this purpose, what we are going to do is whatever wheel load we have calculated, because if you see this figure, so the wheel is when directly acting, or when the wheel is exactly above the what you can say, the corbel, then only the maximum bending moment is going to come. So we have already calculated the bending moments and shear force due to the wheel load. I think here we have calculated, right? So due to the wheel, we have 46.114 and 72.7. So this is 46.114 and 72.7. This is kilonewton meter and this is kilonewton. Okay, so these values are already known to us. So for this purpose only, now we have to go for the design. Okay, because the self-weight part, if you see the self-weight values, they are relatively smaller, and it can be taken care by the bending by the beam itself. Okay, so for this purpose again we have to go back to the design part. So the bending moment, if you see the value, it is 46.114. So here 46.114 into 10 to the power 6. Your Q value is कितना है? 1 point. Q value is कितना था रे? 1.527. Okay, this is 1.527. Okay, and how much width you will be considering over here? width 230, because here you see I have considered the width as 230. Okay, so this will be 230 into d square. Okay, how much is the d now? Sorry, 360.35 mm. ठीक है, और हमने जो डेप्थ एज्यूम की है विच इज ओवर हियर, this is 450, so this is on the positive side. Okay, so even if you add clear cover and everything, it is safe. So finally what we can do is we can assume this depth as 450 mm, and if you take the diameter of the bar as 10 mm, clear cover as 20 mm, so your small d comes out to be 425 millimeter. बराबर है? So with this, let us do the AST calculations. So this bending moment is 46.114. Sigma ST is 130. J कितना है? Your J is 0.86. So this is 0.86 and your D is 425. How much is this? कितना आ रहा है बेटा? Sorry, 977 millimeter square. ठीक है ना, 970.5. ठीक है, so 970 millimeter square, right? So this is the main steel which is required. Okay, so you can see in the figure main steel has to be provided in form of a trapezoidal shape because it will be subjected to bending like this. Okay, so and the shear reinforcement has to be provided as shown in the figure. So for this purpose how much bars are required? 970 के लिए कितने बार लगेंगे? लेट अस से 10 mm डाया बार्स, बहुत ज़्यादा लगेंगे शायद 30 20 mm के 3.0 4 बार लगेंगे. ठीक है, सो हियर what you can do is this is your main steel, so you can say 4 numbers 20 die. ठीक है, it has to be provided in the trapezoidal shape as shown in the figure, right? So the total width, if you see, if you take a cross section over here, okay, so it will look like this. ठीक है, so here this will be 230 and here this will be 300. बराबर है, और तुम्हारा ये रहेगा तुम्हारा shear reinforcement ऐसा, और तुम्हारे जो बार रहेंगे ये 1 2 3, सॉरी ये तो वही बार रहेंगे, 4 बार रहेंगे तुम्हारे 20 के, ये ऊपर भी जाएंगे नीचे भी जाएंगे. इट इज इन फॉर्म ऑफ अ ट्रैपेजॉइडल स्टीरप्स काइंड ऑफ अ शेप. ठीक है, और बचा क्या है तुम्हारा? स्टीरप्स. ओके, सो फॉर स्टीरप यू नीड टू हैव दी फर्स्ट ऑफ ऑल द shear stress. सो shear stress के लिए हम लोगों ने ऑलरेडी वी हैव ऑलरेडी कैलकुलेटेड द shear force that is 72.2. okay, so let us calculate the stress first. So this is 72.2. Your width will be 230 and your depth, okay, so now your depth will be 425. okay, so this is 425. How much is the shear stress now? Sorry, 0.773. न्यूटन्स पर मिलीमीटर स्क्वायर, बहुत ज़्यादा है ना? So let us calculate the steel also. So the main reinforcement we have provided 4 into 20 square, बराबर है? Your width is 230, okay, and your depth is 475. How much is the percentage of steel? 1.4, 1.28%, okay. And if you refer the is code, so 1.28, let us consider 1.25, okay. So if you see the 1.25 corresponding percentage or tau c value is 0.44, ठीक है. So let us consider this as 0.44, ठीक है. This is 0.44 newtons per millimeter square. So definitely here the design is required, isn't it? So first of all, you need to calculate the shear force for design. So actual shear force is something like 72.2 into 10 to the power 3. Your tau c value is 0.44, थोड़ा सा ज़्यादा रहेगा if you go for actual interpolation. Your width is 230, depth is 425. How much is the design shear force? Tell me in kilonewtons. 20.19 kilonewton. Accordingly, now you can provide 2 leg 8 mm die bars or 10 mm die bars. Just give me the spacing. Please answer your attendance. Roll number 1, 2, 3, 4, 5, 6, 7.
Sir.
Aniket, are you there online?
Yes, sir.
Okay, 8. Hardik, Ketan, roll number 9.
Yes, sir.
Sir, I'm present.
Hardik is present, right?
Yes, sir.
Okay, Ketan is also present.
Yes, sir.
Okay, 10. Pronal, 11,
Present, sir.
12, 13, 14. Piyush,
Present, sir.
okay, 15, 16,
Present, sir.
17, 18. सौरभ चौधरी ऑनलाइन नहीं है. ओके, चलो क्विकली डू इट. आई थिंक यू कैन कंप्लीट दिस. ठीक है. So we will stop here.